Welcome back. This is an Aleks homework video on calculating absolute entropy using the Boltzmann hypothesis. Okay, so Boltzmann was a Russian scientist who is extremely useful in thermodynamics because he figured out essentially how the energy if you were to have gas molecules that are slamming together, how is the energy distributed among a big crowd of gases that are slamming together? I just can't believe that there are people this smart. Actually, he put this equation on his tombstone, so I guess if you were that smart, you'd put it on your tombstone too. But this is not hard because he did all the work. He just gives you an equation. You fill in what you're given. This is a 2-second question. So thank you, Mr. Boltzmann. So the first thing that I need is his equation. So this is entropy, capital letter S is entropy. And this is equal to the product of his constant times the natural log of the available adsorption sites. Okay, so all the places that a thin layer of gas or liquid can be put on a solid. Okay, sounds really smart to me. So let me give you something that you may not have grasped yet, and many of you I'm sure have, but entropy is a hard concept. Entropy really is thermal energy or heat energy that's unavailable to be turned into mechanical energy. So it's essentially lost energy, lost heat energy, or chaos, if you want to think of it as chaos. You can't get it back. So that is what it is. How random is this situation? And then your W in this case is the adsorption sites. Now, absorption is an easier concept. You absorb something into something else. You absorb water into paper, for instance. But adsorption is really basically the same idea with a solid, and you are holding on to a gas molecule or to a liquid molecule on its surface, normally as some kind of a thin film, a film of water on the surface of plastic, or a thin layer of gas on the surface of a metal, something like that. All right? So you're just going to fill in what you need. Now you'll look up K sub B in the Aleks tables. It's there. It's one of your constants. So the Boltzmann constant here is 1.38065 times 10 to the negative 23 joules over Kelvin. Now this is from Aleks, and I'm always scared of Aleks's constants because they have to be exactly what Aleks says. So I would not look it up somewhere else. I would not use your notes from your book. I would use this exact number because I think this is what you're going to need in order to get an answer. The rest is quite simple. It's going to be the constant times the natural log of the number of sites. And so the question said you had 1 out of possible 225 sites. And so you'll have the entropy as 7.4777 whatever times 10 to the negative 23 joules over kelvins. And they asked for 3 significant digits. Okay, so problem quite easy if you have some understanding. So I hope this is helping you have some understanding.